Hello again, students. When we finish, we're talking about this example that shows both the difference in spread and center of the distribution. And so we're interested in both of those as we have discussed, and we'll finish that section off with just saying that that the characteristics of the distribution we're usually interested in are the shape, whether or not there's outliers in the data, the center, the typical data, and the spread and the variability. Okay, now we're going to talk a little bit about graphing of categorical variables. As you can imagine, and this is one reason why we spent some time talking about the difference between numerical and categorical. As you can imagine, the graphs that you would do would be somewhat different here. We're going to talk about bar charts and pie graphs as two of our typical graphs. The bar chart is a very versatile graphing tool that fits a lot of situations, and the pie chart is one variation on that we'll talk about. So you see here is this chart says bar charts on the left versus histograms on the right. So a couple of things to keep in mind. You use the bar charts for categorical data, and the histograms are used for numerical. The order on the bars is not that critical. They can be sorted by category. They can be put in alphabetically. They can be put in from high to low. What we're trying to do is compare the different categories to see if some are occurring more frequently than others, and they usually will be. Versus the histogram, where we've got a continuous scale there, and we're dividing it into bins, so we can see what the shape of the distribution. So shape is not the issue so much on the bar chart as much as what we can learn by looking at the magnitude of the bars. So here's an example. Students in a statistics class at UCLA, and you see how many students there were, graduate students, juniors, seniors, and sophomores. Apparently there were no freshmen in those classes, although they have an unknown category, which ended up being quite a few. One thing that's maybe the first time we really introduced this in this class, you see the frequencies shown there. Out of the 20 total students in this class, the number of in each group, there were no first-year students, so that didn't even show up on the graph. But what they did is they plotted the relative frequency over there on the right in the bar chart. Now, the difference between the relative frequency and the frequency is that you simply divide the frequencies by the total number. So 7 over 20, that would give you about 35% or 0.35. So on the relative frequency side, the unknown is plotted as 0.35. You see that the graduate student, we had 1 out of 20, which is 5%, so that's plotted as 0.05 on the relative frequency. So if you multiply those by 100, those relative frequencies would give you percentages. As they are shown right now, they are shown as proportions, and the highest being 0.35 and the lowest being 0.05. But I hope you see where those are coming from. Simply divide the frequencies by 20. And you could have made another column here called relative frequency, and it would have those numbers that are actually being plotted. But the picture, the actual information would look the same whether you plotted frequency or the relative frequency. Okay, I hope that makes sense. So there's a certain type of bar chart known as a Pareto chart. Pareto was a Italian economist. He was the one that observed that 80% of the 20% of the causes create 80% of the effects. You've maybe heard of the 80-20 rule. Well, Pareto was a developer of that, and he was studying incomes. And he said something along the lines that, well, 20% of the people are getting 80% of the income. He probably also concluded he wasn't getting his share. But in any event, that's what the Pareto principle is. So in a Pareto chart, it's just a bar graph where they have been ranked from tallest to shortest. And you see here the lack. This is looking at some kind of errors that you see in some kind of an organization. They say the biggest problem is a lack of training. 55% of the problems were due to that, and then that goes down from there. So 55% based on one cause, and then you look at the two that combine, 55 plus 24 gives you almost 80% right there, and those two items account for 80% of the issues. So if you're going to fix something here, you probably would work on the training and the pay here as a starting point for this particular example. Okay, we're going to also look at the pie chart. This is as literal a pie chart as you would see. You've got a full pie there, and of course you see the part that's been eaten, the part that hasn't. But this is the same idea. You take the whole and you divide it up into groups, the relative percentage in each group that has appeared. Okay, so I'm going to show some pie charts here. The first couple are examples of poorly done pie charts, but apparently this one showed up in a news organization that they had yes 87%, no 13%, and then they showed it as 50-50 on the graph. That's a poorly constructed pie chart, and by the way, the news media sometimes is known for that. So if you happen to be reading the news and see something that looks wrong, bring it in and we'll put it in as an example. That one's wrong. It's that the yeses should have been shown as 87% of the chart. And in this one, what did they do wrong? It's basically sales from burgers, and you see that they took 4 of the big ones from McDonald's to Wendy's, but that doesn't make up 100% of the share. So you've got 15%, 16% plus another. It's about 32% of the market, and they're showing it as a complete burger in this case, or pie. So this is a problem because they're not showing the entire pie that adds up to 100%. So this is also in the news in USA Today. I find that interesting because USA Today usually does a much better job of this. But it does show the McDonald's is about 4 times as big as Hardee's or Wendy's, but not appropriately done. Okay, now here's a better pie chart, and I'm going to show you a couple of these. So this is the one we were just looking at, and you see how the data from that bar chart is split up now by the relative frequency. So unknown being the biggest category, and then it goes from there. So these percentages correspond to the relative frequencies of those groups. And this is my favorite pie chart. I call this a pie chart classic. Victims in horror movies. So the big area there, let's see, you've got 4 categories. Logical, smart people. There are very few of those. People who mourn over the dead, and there's several of those get it. And then people who run from the killer, but of course get caught because the killer can walk faster than humanly possible. So those killers in the horror movies tend to show up anywhere and everywhere. So like, how do they do that? They must be cloned. And then the last category, if any of you have seen the Geico commercial that they show in the U.S., it's pretty funny. It shows horror movie victims doing exactly this. People who do not run are split up, so it's easier for the killer to find and kill each one of them. Like, that's what happens in all the movies. They do dumb things anyway. So this is made up data, but it's a humorous take on pie charts. Okay, that's the end of that section. We're going to move on to 2.4, and we're going to talk a little bit about summarizing categorical distributions when we see these bar charts. So what things do we look at? We're obviously not calculating a mean when we have categorical data. We're not looking at shape, outlier, center, and spread, but since there's no inherent order in categorical data, those don't make sense. So what we're interested in categorical distributions are shown here. We're interested in the mode, which is the most frequently occurring value or values, and we're interested in variability or diversity. Did we tend to get just 1 or 2 results, or do we get a lot of different results? All right, so we're going to look at those two. So the mode basically here is the one that's the tallest, the most frequently occurring value where we have the most results. So in our that university class, the UCLA data, they had 7 ones where they didn't know what their class was, and that was the biggest group. So that would be the mode. And we could use the same wording as before, unimodal, if there's 1 distinct one, 2 if we have a lot of groups and there's 2 that are higher than all the others, we call it bimodal. And if there are a lot of high ones, if it's a lot of categories and there's a few modes, we could call it a multimodal distribution. Okay. So here's a survey of where they asked 2,508 Americans which economic class they identified with. Lower, middle, or upper class, and there are a few that said they don't know. What's the mode here? Well, it's pretty obvious, right? That the most frequently occurring value, about 50% of the people identified themselves as middle class Americans. Okay, I hope that makes sense, and that we would call that the mode. All right. Now that particular data set, by the way, there is some order to that one, but you get it. Any one of those could have been the mode. Here is a bar chart of the ethnic compositions of 2 schools in the Los Angeles City school system. And one of the things that's clear is that there is more diversity in School A than there is in School B, which is a primarily Hispanic population. Hispanic is the mode in both of those, but there's more diversity or more variability in the one School A certainly than there is in School B. And that variability is diversity, if you will, is an indication of the difference in these 2 schools in their ethnic makeup. So think of the variability as diversity in the categories. It's more about the occurrence of many different categories rather than the spread that we talked about in the numeric data. Okay, we have one final section here, section 2.5 from the textbook, where we're going to talk a little bit about just picking the right graphs and then interpreting. So numerical data, we look at dot plots, histograms, stem plots, and simile diagrams, as we call them. And on the category, we talk about pie charts, bar charts, and there are some other types of graphs. And then the tables, frequency tables, we've talked about as well. Box and whisker plots, we're going to talk about those in Chapter 3. Really a great plot, particularly if you have multiple groups to compare to one another. But that one is going to be covered more directly later. So, and the measures that we use on the numerical data then would be different than the categorical data. And when we move on to Chapter 3, we will see that. Again, one of the key reasons for distinguishing numerical from categorical data is because the procedures that we would use on them are different. So, and that's shown already in this graph. One thing to be aware of, I'll tell you the very first book I read on statistics. It just caught my attention. It was called How to Lie with Statistics. Now, the goal of any good data analyst is to extract the meaningful information in the graph, in the data. But there are people who tend to distort things and so on. And so so that book was just full of examples of how people had, and many of them were news media examples, tend to distort things to tell a certain story. So this is an example of that. You see what's being graphed here is the number of murders committed using firearms, and I think we're looking specifically at Florida. But what did they do here? Well, 0 is at the top of the graph rather than at the bottom. So they've inverted the graph so that the higher this graph goes, actually the fewer the murders have been. So they made it look like in 2005 they enacted some kind of stand your ground law, and they made it look like murders went down, but actually what they did is they went up. And this thing is really designed to lead to the wrong conclusion. That's a cardinal sin, and we should never be doing that. And this is really a poorly constructed graph. These are examples of more examples of poorly constructed graphs. The one on that upper right really is, you see it's the percent satisfied, and it makes it look like Chevrolet is like 10 times better than Toyota or Ford. Well, you see that graph starts at around 94%, and they're all higher than that. So the difference between those, well, it might be important. Certainly, if you're Chevrolet, it's shown in much more dramatic fashion than what is deservedly there. So that's a distortion, and so that graph should start at 0. And if it doesn't, there should be a symbol on there to indicate that they did start at 0. And you see on the lower right, this is a very common kind of thing to do. The trash example, you see that what they did was the trash can not only gets taller, but it gets bigger. So that the increase in area makes it look like even a bigger difference than what you would see if it was a regular bar chart. So the bars are like getting wider, in the shape of in the fact that the trash cans are getting wider as well as taller, which is a distortion.